Hello, welcome to Notes on Inverse Functions. Inverse functions are the result of undoing the operations in the original function. And most of the time people recognize this by just swapping x and y, the input and output variables. So undoing operations is really important here, and it's going to be the main algebraic skill we use. A lot of the rest of an inverse is just understanding the concept at its core, which we'll see with these graphs. So in this first example, find the inverse of this parabola, 3x squared minus 2. And x is restricted to 0 to infinity. We'll get into why this is important later, but just swapping x and y and rewriting this function so that we even have y in it is important, because we're not used to working with function notation, which is, remember, that's what f of x is saying. That's just function notation for the output. And as we go, we'll swap x and y just so we can start to undo this original function. And then when we solve for y, we are getting this radical, and we'll replace y with f of x inverse equals radical plus or minus radical x plus 2 over 3. Alright, so I've solved that, and we swapped x and y. We found an equation that looks like it could be the inverse. Now, graphically, inverses can be spotted because they'll be reflected across y equals x. That's just because we've swapped x and y, so we've traded their positions. So the inverse graph, that orange one, is a reflection of our original graph. Now, notice here, I didn't include the negative version of this radical that I found for my inverse function. In fact, this radical function, if I was going to just put in the dashed line for it, this radical function is not a function because it fails the vertical line test. So we don't want to include that piece. Now, functionally, that makes sense, but how do you know that's not going to work? How do you know that piece is not going to work from the get-go? Well, that has to do with how our original graph is restricted. It's only 1/2, it's the right half of that parabola. So we know that we are not going to be including this negative version in our answer because it's just quite simply not the reflected version of our original function, y equals 3x squared minus 2. So we do not include that part. So it would be wrong to say that this is plus or minus radical x plus 2 divided by 3. Cool. Now, here's a little bit. Not all functions have inverses that are functions, which is what we've just discovered, which is why we have restricted this orange graph to be just the top half, because the resulting inverse fails the vertical line test. And in order to spot a function will have an inverse function, we use the horizontal line test, which here, if we graphed the original function without the restriction, then it would fail the horizontal line test. That's how we would know it would also, its inverse would fail the vertical line test. Functions that fail this test must be given to you with a restricted domain, which we discussed, and if a function passes the vertical and horizontal line test, then that function is 1-to-1. And being 1-to-1 means there's a unique x for every unique y. So these radical functions, this orange radical function is 1-to-1. That half of a x squared function is 1-to-1. Okay, so for this practice, we're going to be determining the inverse function. From f of x in each case. So I'm going to go ahead and knock out the first two, and I'll meet you at the third. Here we are at our last example. This one is a little weird because our result will end up needing to be restricted. So for the same reason on a quadratic that we had a restriction in our starting function, you'll see why we need a restriction in our answer. So I'm going to go ahead and swap x and y well after rewriting. Rewritten, I'm going to go x minus 4 divided by 6. I'm going to do a lot in one step there. And now I'm going to square each side. So I have x minus 4 over 6 squared equals y. And this looks like a parabola. So I'll write f inverse of x equals x minus 4 squared over 36. It might be a parabola that's squashed vertically pretty well, because this can also be written as 1 over 36 times x minus 4 squared. But that's alright. This quadratic, if we were to graph it in red, we'll graph the original radical. The original radical is shifted up 4 and it's stretched a lot vertically because it has that 6 there. And then the inverse function will be moved right 4, and then it's squashed a whole lot vertically. And it'd be cool if this equation just meant that right piece, because the right piece of that quadratic does reflect well across the y equals x line, but it doesn't. It has the left piece as well. So if you are ever in this situation, then for your answer you need to restrict the domain. So you need to say X is restricted to for, which is where the right half begins, for including 4, and then going to infinity. And that's because we have a clear reflection beginning at 4. So there you go. That's the notes on finding an inverse and making sure you have restricted domain if you need to for your answer, and making sure you are reading the restricted domain correctly for something like this one that's given to you.